x plus c equals 0. The quadratic formula is to solve for x when the equation is in standard form. So here's the quadratic formula. Hopefully you guys saw that in Algebra 1. And tomorrow in class, I will show you a little video clip of a way that might make it easier to remember the quadratic formula because it's a lot to keep track of. But it's x equals negative b plus or minus the square root of b squared minus 4ac. So remember, the a, b, and c are coming from the standard form, and then all over 2a. The discriminant is going to tell us how many solutions we have to our quadratic equation, and the discriminant is the part that's under the radical, the b squared minus 4ac. All right, so today we're going to be looking at solving a quadratic equation in standard form and determining the number of solutions for a quadratic equation. So our first equation is x squared plus 5x minus 14 equals 0. So you want to identify your a, b, and c. A is the coefficient of x squared, b is the coefficient of x, and c is your constant. And then you substitute those values into the quadratic formula. So we have that here again, so you can see my direct substitution. The opposite of b, the opposite of 5 is negative 5. B squared minus 4 times a times c all over 2a. So I just showed my direct substitution on that one, and then we start to simplify. Remember, we're not going to use a calculator for our square roots to get a decimal. So we have negative 5 plus or minus 5 squared gives us 25. The negative 4 times negative 14 gives us a positive 56. And then, of course, 2 times 1 is 2. 25 plus 56 is 81. And since 81 is a perfect square, we're going to go ahead and take the square root of that. And then we'll simplify. So I'm going to turn this into two different expressions. Negative 5 plus 9 is 4. And negative 5 minus 9 is negative 14. And then 4 divided by 2 is 2. And negative 14 divided by 2 is negative 7. All right, so this one we have a coefficient in front of our x squared. The problem is that coefficient is negative. Now you can use the quadratic formula with a negative a, but the simplifying at the end gets kind of tricky. So what we're going to do instead is just divide everything by negative 1. So we end up with a new equation of 3x squared minus 9x minus 5, and of course 0 divided by negative 1 is still 0. So our a is a positive 3, our b, the coefficient of our x, is negative 9, and c is our constant, which is negative 5. We got the quadratic formula here again, so we're just going to direct substitute right into the quadratic formula. This time our b is negative, so right here this negative means opposite. So the opposite of negative 9 is positive 9. And what I do when I substitute a negative b under the radical, I know that once I square that value, it will become positive. So I just drop the negative in the first place, and then it gives me less to worry about when I'm simplifying. There's enough going on with this formula. 4 times a is 3, and c is negative 5, all over 2a. Starting to simplify, 9 squared is 81, and then the 4 times 5 is 20, times 3 is 60, the negative times negative gives us a positive, and 2 times 3 is 6. 81 plus 60 is 141. Which has no perfect square factors. So it's as simplified as it's going to get. This equation is not equal to 0. You cannot use the quadratic formula until you have your equation set equal to 0. And because I want the coefficient of my x squared term to be positive, instead of moving that over, I'm going to move both the 8 and the negative 3x over. So I'm going to add 3x and subtract 8. Make sure that you write it in standard form with your x squared term, then your x term, and then your constant, so you don't have to think as much about which one's a, b, and c. So the coefficient of x squared is 4, coefficient of x is 3, and our constant is negative 8. I don't know why I don't have the quadratic formula in this one, but let's write that down again. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Substituting b is 3, so it's the opposite of 3, plus or minus square root 3 squared minus 4 times a, which is 4, times c, which is negative 8, all over 2a, which is 4. Okay, so starting to simplify. 3 squared is 9, and 4 times 4 is 16, times 8 is 128, and again that negative times negative gives us a positive 128, and 2 times 4 is 8 in our denominator. So 9 plus 128 is 137, which again does not have any perfect square factors, so those are our two solutions. Again, negative 3 plus the square root of 127 over 8, and negative 3 minus the square root of 137 over 8. This one, we don't have a constant. So there's a couple of different ways to do this one, but if we're using quadratic formula, our a is 1, our b is 3, and our constant is 0. We're not adding or subtracting anything. So we got x equals the opposite of b, or negative b, plus or minus square root b squared minus 4 times a times c all over 2a. When we simplify under the radical, we get negative 3 plus or minus the square root of 9 minus 0 all over 2. Square root of 9 is 3, because of course 9 plus 0 is 9, so the square root of that is 3. Again, we got an integer, so I'm going to simplify this to my two answers. Negative 3 plus 3 is 0, divided by 2 is 0. And negative 3 minus 3 is negative 6, divided by 2 is negative 3. In our last example, we have one that is not already in standard form. If this were equal to 0, we could use our zero product property, but because it's not equal to 0, we can't. So we're going to go ahead and multiply this out. X times x is x squared. X times negative 2 is negative 2x. X times 1 is 1x. And 1 times negative 2 is negative 2. Now to get this into standard form, I have to have it equal to 0 before I can use the quadratic formula. So I'm going to simplify my like terms. Negative 2x plus x is negative x. And then negative 2 minus 5 is negative 7 when I subtract that to set it equal to 0. So this time my a is 1, the coefficient of x squared. Coefficient of x is negative 1, and our constant is negative 7. So x equals the opposite of b plus or minus square root b squared. Again, when b is negative, I drop that symbol because I know it will become positive once I square it. Minus 4 times a times c all over 2a. Simplifying under the radical, 1 squared is 1. 4 times 7 is 28. And 1 plus 28 is 29. And again, 29 does not have any perfect square factors, so that's as simplified as we're going to get. So that's solving a quadratic equation with the quadratic formula. The next piece will be determining how many solutions a quadratic equation has. And there's 3 different possibilities. The discriminant tells us whether or not we'll have a solution. So if what's under, remember this discriminant in the quadratic formula is under the square root. If we take the square root of a positive number, we get two answers. We get the positive and negative. That's where that plus or minus sign comes from in the quadratic formula. If we get 0 under the radical, the square root of 0 is 0. And so when we add or subtract 0, it's the same thing. So we end up with only one solution. If what's under the radical is negative, we can't take the square root of a negative, so we get no solutions. So graphically, what this looks like is either the first graph here, it intersects the x-axis twice. What we're doing when we're solving quadratic equations is we're finding the x-intercepts. We're substituting 0 for y, if you're thinking about it with a graph, the y equals, and solving for x. So those give us the x-intercepts. If we have that second option, where the discriminant is 0, we have a graph that touches the x-axis. The vertex is on the x-axis. So we get one solution. And the last graph shows us what happens if the discriminant is negative. A parabola does not have to intersect the x-axis. So it could have the vertex below the x-axis and open down, or above the x-axis and open up. All right, so all we're going to do on these last few examples is find the discriminant. That's the b squared minus 4ac. And then we're going to tell how many solutions based on the answer that we get. So our a is 2, our b is 4, and our c is 1. So substituting that just into the b squared minus 4ac, I have 4 squared minus 4 times 2 times 1. 4 squared is 16. 4 times 2 is 8. 16 minus 8 is 8. This is a positive number, so when we take the square root, we will get 2 solutions. Our coefficient of x squared this time is 4. Our coefficient of x is negative 4, and our constant is positive 7. With this one, again, you can drop the negative. B squared is the same as 4 squared minus 4 times a times c. 4 squared is 16. 16 times 7, I did not work this one out ahead of time. We get 70 plus 42, which is 112. And when we subtract, we get negative 96, which is negative. We can't take the square root of a negative, so there are 0 solutions. And that is it. That's how we use the discriminant to determine number of solutions. So we will take a look at quadratic formula. Like I said, I will give you a song in class, which will make it easier for you to remember that formula, and then we'll have a few problems to look at.